said, anybody know what they're cooking up there? I don't think it's Bananas Foster, but it's something like it. Anybody know what Bananas Foster is? Huh?
And like Zion putting on fire.
Bananas Foster was made famous by a restaurant called Commander's Palace in New Orleans by a chef by the name of Paul Prudhomme. What they do is they take and they put in the pan, they put some sugar and they melt it, they caramelize it, they put bananas, they cook the bananas in that caramelized sugar, and they put some brandy in it, and then they flambe it by lighting the alcohol on fire, and that's what they're showing us. That technique of cooking is called flambe, where you burn off the alcohol, right? Kids in the other class, that's kind of scary that you know about a restaurant like that, and you know the history of the dish and everything. It's like, Commander's Palace is a pretty famous restaurant. I mean, it may be one of the most famous in the United States. So, it's really good. It's very expensive, but it's good. So, this is a combustion reaction, right? Just because it has OH or hydroxyl in it doesn't mean it can't undergo combustion. You can burn alcohol molecules, right? Like you said, as kids in high school take the hand sanitizer and light it, they're burning the alcohol. Okay? Alcohol, everybody ever seen it? Like if you take microbiology, they have alcohol burners in there. Okay, with a little wick that comes up and you light the alcohol on fire, right, with the wick. So the products are still carbon dioxide and water, just like with any combustion reaction. The hydroxyl goes to make water molecules. Okay, so alcohols can combust. Now, if we have an alcohol, remember last week we talked about hydration for an alkene? Well, the reverse of hydration is what? Dehydration. So now we're going to take an alcohol and we're going to take the hydroxyl off. What do you think we're going to make? An alkene. It's the reverse of the reaction we did last week when we hydrated an alkene to get an alcohol. Now we're going to take an alcohol and we're going to dehydrate it and make an alkene. Okay? Same reaction. We're not going to spend a lot of time on it. If you understood what hydration was, adding hydrogen and oxygen and hydroxyl to them, now it's just the reverse. We never called that an alcohol molecule last week, this one, but now you know. The product of a hydration reaction is an alcohol molecule. Okay? Now, oxidation reduction involves the transfer of electrons, but you can also think about oxidation as adding carbon to oxygen bonds. So instead of being C single bond O, maybe we go to C double bond O. That's an oxidation. Reduction is getting rid of carbon to oxygen bonds. So maybe going from C double bond O back to C single bond O. Examples. Here we have an alkene, or an alkane, sorry. When we oxidize it, we can oxidize it to an alcohol. If it's a primary alcohol, we can oxidize it further to a aldehyde. Aldehydes can be further oxidized to carboxylic acids, which we'll get to in a few minutes. Okay? So each time, note here we didn't have any carbon to oxygen bonds. Here we have one, here we have two, here we have three. So each step, it's increasing in the number of carbon to oxygen bonds. It's being oxidized each time. Okay? So here we have an alcohol. When we oxidize it, this is a primary alcohol, right? Because there's one thing here, so that makes it a primary alcohol. We oxidize it, we get an aldehyde. Okay? So primary alcohols get oxidized to aldehydes. This aldehyde can be further oxidized to what we now call a carboxylic acid. Look at this over here. This carbon is a hydroxyl carbon, but it's also a carbonyl carbon, isn't it? So it kind of has two functional groups on the same carbon. And that's why this is called a carboxylic acid. Okay? Does everybody see that?
And carbonyl again means?
C double bond O.
Okay.
This is my carbonyl group right here, up and down. This is hydroxyl over here. Secondary alcohols get oxidized to ketones. Because here's my alcohol, right? Here's my hydroxyl. If I'm going to get rid of that hydrogen in this hydrogen, I now have C double bond O right here. Can this be oxidized further? Can this now become a carboxylic acid? So can I add OH onto here?
No,
Why not?
because it can't have 5.
Because it can't have 5 bonds once again. So you cannot, oops. So secondary alcohols can only be oxidized to ketones, okay? Now, tertiary alcohols cannot be oxidized at all. Because look, it already has 1, 2, 3 bonds like this. I can't take and make a double bond up there. That doesn't work, okay? I can't do that. So tertiary alcohols cannot be oxidized, okay? You see how primary, secondary, and tertiary determine the reactions that an alcohol will undergo? It's going to be the same thing when we talk about proteins.
Can you go on that one more time? What
What?
did you draw on there?
I try to draw, if I have COH like this, and I want to oxidize this, that means I'm going to get rid of this and I'm going to add a bond like that, right? Can I do that?
Oh, okay.
The answer is no, because now it gives me 5 bonds, right?
Okay.
So this does not work. Okay? So tertiary cannot be oxidized any further. It stays like it is. So here we have methyl alcohol being oxidized to formaldehyde, which is an aldehyde, and then the formaldehyde being oxidized to formic acid. Anybody know where you find formic acid at in nature? This is a little sidebar. This is my favorite acid, formic acid. Gotta be a nerd to have a favorite acid, right? Where do you find formic acid at in nature? What about ants? When they sting you,
That's in their body.
they inject you with formic acid. That's cool.
Really? We're the only insect that does that?
Yeah.
So
Ants, when they sting you, they inject you with formic acid.
So when
Sorry,
you're
she
allergic to
said-
ants, is that what you're allergic to?
Yes. That's my favorite acid.
Fire ants, right, or all ants?
Fire ants. Most ants
Is that
don't
the same
inject
stuff
you.
that's in wasp?
No, I think that's different. That's a different compound. That's why you react differently to a wasp sting you to an ant bite.
I react the same way, I blow up like a balloon.
You know, most people, I don't for either one. Ant bites are small, wasp bites too. It's actually a larger molecule than this. This is a pretty small molecule, right? But they inject it and it starts to digest you. That's why, like, it often gets like pussy or festers up, right? It gets nasty looking because of formic acids in there. It starts to disrupt some of your cells and stuff.
Just that small amount.
Yep. And like those big killer ants in the jungle and stuff, when a million of them bite you, that's not good, right? It can actually kill you.
Like Indiana Jones and I'll eat you.
Yeah,
Sorry.
like that.
Oh.
Just like that. Now with sulfur, with thiol molecules, they can actually also be oxidized, but they form a linked disulfide bond. So here we have 2 thiols, right? This makes it a thiol with sulfur, but notice what happens. They lose the hydrogen and they make a sulfur-sulfur bond here. This is actually the link that is responsible for your hair being the way it is. Your hair is actually just a long chain protein molecule.
So can it change like somebody that's born with naturally straight hair undergoes some kind of medical condition and then some change, I mean,
The curly hair?
I've
Yes.
seen puberty do
I
that.
have no idea.
I know, and
Why don't you go to the cosmetology building and ask
they
those
don't
people?
know.
They don't know?
my mom
For
said.
some women, whenever you get pregnant, they can change your hair.
Yeah.
It does, well, that happens to me, but yeah.
All I know is that mine is changing color over time.
Oh, that's great.
That's normal.
At least you're not
And then
losing
you
it,
go
at
bald.
least you're not going bald.
I don't know the answer to that. I know a lot of other useless stuff, but not that. So here's what happens in your body when you drink ethanol. It gets oxidized to an aldehyde, ethanol, and then that aldehyde gets oxidized further to carbon dioxide. So it doesn't make a carboxylic acid. It doesn't make that. It actually breaks it apart, makes carbon dioxide. And you actually respire it then, right? So, and I don't know why they want to give the statistics on alcoholics' rate of use of alcohol,
Why do alcoholics usually turn red, like their skin?
because this process generates heat. Your body's trying to get rid of the heat. So the blood is flowing real close to your skin and trying to dissipate the heat. Because what they're actually doing is burning alcohol in your system to oxidize it. Oxidation reactions are burning reactions. When you burn a piece of wood, that's an oxidation reaction. And that's actually what your body's doing with the alcohol. It's actually burning it to create CO2 and water. And that's why they often have very red nose is the first sign, right? Yeah. Yeah, we don't care about what.
How come they got something here, alphanoic acid?
Ethanoic acid, yes.
Is that different from
That was,
the byproduct of?
yeah, because ethanoic acid, theoretically, you could have another step in here to make ethanoic acid, but I don't think our body makes ethanoic acid.
Oh, okay.
I think it actually that would, if you weren't gonna make CO2 and water, that would be the next logical step for the oxidation, right?
Okay.
But our body actually oxidizes it to CO2 and water. Because ethanoic acid would be toxic for you.
All right.
So we metabolize it to CO2. I don't really care about Toland's test. Benedict's test, we'll see that eventually. Reduction of alcohols and aldehydes. Well, if oxidation was adding carbon to oxygen bonds, reduction is doing what? Taking carbon oxygen bonds away, okay? So here we have an aldehyde, propanal. When we oxidize it, or when we reduce it with a catalyst, we actually make an alcohol, okay? And that alcohol, and then they have a ketone that gets oxidized to an alcohol. So, if we could do these, we'll be good. Select a product for the oxidation. So let's look up here. Here we have, here's our key component right here, right? We're gonna oxidize it. What are we gonna do when we oxidize it? We're gonna increase what? What are we gonna increase when we oxidize this? CO bonds, okay? So which molecule down here has more carbon to oxygen bonds than we started with up here? This doesn't even count. I don't know what that is. B does, doesn't
It's
it?
the only one.
It's the only one, right? This is actually the same molecule. This one doesn't have any oxygen in it. I don't know what that is. That would be reducing it. This one actually goes from 1 carbon oxygen bond to 2 carbon oxygen bonds, right? So we started with we're kind of about the secondary alcohol being oxidized to a, what is that? What is this molecule here? Aldehyde or ketone?
Ketone.
To a ketone, right? Now this is a 2-step oxidation, okay? You're gonna start with this guy here, you're gonna oxidize it once, and then oxidize it a second time. What do you get after the first oxidation? Oxidation means what? Adding carbon to oxygen bonds. So which one are you gonna get? Which molecule down there adds more carbon-oxygen bonds? 3 to start with. And then when I oxidize it further, I get number 4, don't I? Number 3 is an aldehyde, and number 4 is a carboxylic acid. Okay? So, step 1, this is a primary alcohol. Step 1 produces an aldehyde. Step 2 produces a carboxylic acid.